Okay, so problem 3 from homework 5 involves an implicit function, which is x to the 4th equals x squared minus y squared. And we're asked to do several things involving this function. So first we have to sketch a graph so we have an idea of what this looks like. And it turns out it's a sort of figure 8 pattern, something like this. So that's something that you could just check by, for example, using some graphing program like Wolfram Alpha that's available online. So next, we're asked to find a formula for y prime. So in order to do this, we're going to use implicit differentiation. So we want to take the derivative of both sides of the equation. So we have something like this. If we calculate these derivatives, we'll get 4x cubed on the left equals 2x minus 2y y prime. So remember, we get this extra y prime here because y is itself a function of x, so we have to use the chain rule. So now that we have this equation, we can solve for y prime. So let's see, we first move the 2x to the other side. So we'll get 4x cubed minus 2x. Then we have this 2y in front of the y prime, so we divide by that. And we'll get this for our answer. So that's our formula for y prime. Next, we're asked to find where does the function have a horizontal tangent line. Well, a horizontal tangent line means y prime equals 0, which means the numerator of this function has to be 0. So 4x cubed minus 2x equals 0. We'd like to solve what values of x make this true. So if we factor this thing, we can pull out an x. We get x times 4x squared minus 2 has to equal 0. So we get a few possibilities. X equals 0. Let's see, another possibility is that x equals plus or minus 1 over square root 2, it looks like, right? So if we solve this term here equals 0, then we get x squared equals 1/2, so yes, this. So there's 3 possible x values. Now we need to figure out for these x values, what are the corresponding y values? So if x equals 0, then we have, from the original equation up here, negative y squared equals 0. So that means y equals 0. So 0, 0 is one candidate point. But if we look back at our graph here, you can see fairly clearly there is not a horizontal tangent line. And this has to do with the fact that, in fact, the tangent line is not well defined here. So 0, 0 is excluded, as tangent line is not well defined there. Okay, so what about these other 2 points? If x is one of these two, well, let's plug that into our equation up here. 1/2 to the 4th power, doesn't matter whether we have a plus or minus sign, we'll get that becomes, we square it, we get 1/2, we square it again, we get 1/4. Then that should be equal to x squared, which is 1/2 minus y squared. So now we'd like to solve for y. Well, if we move the 1/2 to the other side, we'll get negative y squared equals negative 1/4. And this implies that y is equal to plus or minus 1/2 if we divide by the negative and then take square root both sides. So this gives us 4 horizontal tangent lines. So the points are 1 over square root 2, comma 1/2, 1 over square root 2, comma negative 1/2, right? Because if x has the positive sign, y could still have either a positive or negative sign. Then the other possibilities, we could have negative 1 over square root 2 for x, and then y could be either plus or minus 1/2. And if you look up at the graph, this makes sense because we have a horizontal tangent line at these 4 points, and they differ just based on changing x to positive or negative and changing y to positive or negative. So this is in line with what we see on the graph. Now let's try to find where there's the vertical tangent line. So vertical tangent implies the denominator in y prime equals 0. So that means 2y has to be equal to 0. What does this mean? Well, it must be the case that y is equal to 0. That's the only possibility. Let's go back to our original equation. If y is equal to 0, what could x be? So then x to the 4th has to be equal to x squared, is what this tells us. If we rearrange this, we get that x squared times x squared minus 1 must be equal to 0. So this implies that x equals 0 or x is plus or minus 1. So again, 0, 0 is excluded. But the other 2 points do give us vertical tangent lines. So y equals 0 and x is 1. And y equals 0 and x is negative 1. So at these 2 points we have vertical tangent lines. And then we sort of already looked at the answer to E. The place where the tangent line is undefined is this place at 0, 0 where the function intersects itself. And we can clearly see from our calculations that strange things were happening there, right? At 0, 0, the numerator and denominator were 0, and so it was sort of difficult to tell from this equation what's going on. Certainly this equation is not valid at 0, 0. And it's clear from the graph that the tangent line there is just not well defined at all. And so at 0, 0, there is no well-defined tangent line. So that's how you can go about doing a problem of this sort. You first find the derivative using implicit differentiation. Any points where you see self-intersections, that typically will mean that the derivative is not well defined there. And then you can find horizontal tangent lines by setting the numerator equal to 0, vertical tangent lines by setting the denominator equal to 0.